Now we will be characterizing the diode using an oscilloscope. An oscilloscope is a device that can measure the voltage, and we will be applying a AC voltage across our circuit, which consists of a diode and a 1 kilo ohm resistor, and plotting both the voltage of the diode and the voltage of the resistor on the oscilloscope. So the y-axis, for example, will be the voltage of the resistor, which is proportional to current via Ohm's law, and the x-axis of the oscilloscope will be the voltage of the diode. So the voltage we'll apply will come from the wall. So we have a AC adapter here, or transformer. So the input is 120 volts, 60 hertz from the wall. The output from this will be, it says 6 volts. So we will measure that. If we plug it in here, and it has an on and off switch, so we can turn it on. I have the multimeter. So now we're measuring AC voltage. Before we were measuring only DC voltage. So we switch it to AC voltage. And if we probe this, it says 7.5 volts, so a bit higher than 1.5 volts higher than what it is said on there. So 7.5 volts, but that is the root mean square voltage of the sine wave, of the AC sine wave. So if you want to calculate the peak voltage, you would take 7.5 volts and multiply it by the square root of 2. So a little bit above 10 volts is from the middle to the peak, or rather the peak to peak voltage of this is going to be a bit over 20 volts coming from here. And in fact, to demonstrate that, we can show that peak to peak voltage from this on the oscilloscope. So we'll do that. This is a BNC connector. So the BNC connector has a wire in the middle, and the wire in the middle is isolated from the outside. So it has two isolated channels. So we can plug this into channel 1, for example. Okay. And I will attach alligator clips. And then we will attach it to our power supply here. Let's turn on the oscilloscope. Okay, and then we'll turn on this. Okay. So this is showing the sine wave, the voltage that's being measured across this. So there's some different things. I had already calibrated this, so it looks nice to begin with, but usually maybe it's not so clear to begin with. So there's some different knobs here. For example, this knob here controls the frequency that we're looking at. So right now it's set to 2 milliseconds, which means per division. So it means every one of these black lines on the oscilloscope is measuring out 2 milliseconds. So if we count this, starting here for the sine wave, that would be 2, 4, 6, 8, 10, 12, 16, 18. Did I count right? Shouldn't be that high. 2, 4, 6, 8, 10, 12, 14, 16. A bit over 16 milliseconds is the period of this sine wave. And that corresponds to 60 hertz. So if you take 1 second divided by 60 times per second, it's about 16, a little bit over 16 milliseconds, which is what we see here as well. And then this knob can control the voltage range, right? So right now we have it set to, says 5 volts per division. So that's these horizontal lines. So from here, you count 5, 10 volts. So remember I said, even though we measure with the multimeter, it's 7.5 volts, but you have to remember that's 7.5, that's the root mean square voltage where the peak voltage is actually a bit over 10, and then peak to peak voltage is a bit over 20 volts. So we will be using this sine wave and apply it across our circuit, which is the resistor and the diode, and we'll be measuring both the voltage of the diode and the voltage of the resistor using two channels on the oscilloscope, and we'll plot those two channels, just voltage of the diode versus voltage of the resistor. So we can turn this off. We'll set that circuit up. Okay. So we're going to take one lead from our power supply. This will go into the diode on the anode of the diode. Take the other lead from the power supply, connect that to the resistor. So now, if we turn this on, and you don't see anything, but we have an AC current flowing through this circuit. And I'll turn that off. Okay? So now we want to probe the diode voltage. So we can do that now. Let's see. Okay. So that's what it looks like in this oscilloscope. But we're also going to put a second channel to also measure the resistance, the voltage across the resistor. So I have another one of these BNC connectors. And I'll plug that into this channel over here. Okay. And what we're going to do is we're going to establish a common ground, and that will be the point, the junction between the diode and the resistor. So the negative of this, which will be ground, will be the same wire as the negative of this. So basically we're connecting these two together on here. Okay. And then this will be the other side of the resistor. Okay. So I think we can change, right now we're just looking at channel 1, we can change to channel 2, and that's what the voltage across the resistor looks like. So channel 1 and channel 2. Oh, I forgot to mention, I haven't looked on the camera. Yeah, you can adjust the intensity and also the focus of this. This is I believe a cathode ray tube. So we have an electron beam shooting, and it's being rastered. And this is a fluorescent screen that's making it appear. So we're going to adjust that to make it look better on the camera. That should be good. Okay. So now what we'll do is we're going to, it's still plotting the voltage in the y-axis versus time in the x-axis. So we're going to change it. Let's go to here. What we'll do is we can switch a setting on here to ground so that we're just measuring the reference point ground. And then on this, the seconds per division, there's an option that switches it to an XY plot. So now you just see, it's a little hard to see, just this dot appears, and that will be our reference potential for this plot. So that is, basically we're establishing our origin, which will be ground. So we can use the horizontal position and the vertical position to try to get this to the center of the graph. Okay. All right. Now we can switch. If we switch back here, it doesn't make sense. But remember, we're in the XY mode here. We're going to switch back to the other setting, the scanning setting. And now we see our plot. So remember, the x-axis is the voltage across the diode, and the y-axis is the voltage across the resistor. However, remember, since we made these two the same point, ground, the voltage across the resistor is going to be opposite sign. So we can inverse the voltage across the ground by flipping this switch here. So now this is the proper the way it should look. Let's see, I'm going to check one more time. It doesn't look like it's center. I might have Okay, I didn't make it center on the y-axis. Let me put it here. Okay, and we'll flip back. All right, so this is our IV curve for this diode. And so the x-axis could be voltage across the diode. Y-axis is voltage across the resistor, but it's proportional to current. So you can think of the y-axis at this moment as current. All right, and we can zoom in on this. I'm going to zoom in on the x-axis voltage. All right, a little bit, and we can do the y-axis voltage, which is like current. All right. Okay. So right now we're at a division of 0.5 volts per division on the x-axis. So you can see where the cutoff voltage is for this particular diode. So this is 0.5. So it's between 0.5 and 1 volts. So about 0.6, 0.7 volts is the cutoff voltage for this diode.